To truly grasp the scale of the phenomenon we're discussing, we must travel back in time to the Carboniferous period, roughly 359 to 299 million years ago, and wipe the mental slate clean of all familiar landscapes. Forget the continents as you know them. They were all fused into one gargantuan landmass called Pangaea, straddling the equator in a warm, humid embrace. The entire interior of this supercontinent became the stage for the most extensive biological experiment in Earth's history, the rise of the giant rainforest. The climate was uniformly tropical, with no seasons as we understand them, just perpetual warmth and relentless, drenching humidity. This was the perfect incubator. But the real architects of this green empire were not the animals, which were mostly small amphibians and early reptiles scurrying in the undergrowth, but the plants themselves, and they were unlike anything alive today. This was the age of the pteridophytes, the ferns, horsetails, and club mosses, but these were not the delicate ferns that adorn your living room. These were botanical titans. A giant club moss looked like a colossal, scaled telephone pole topped with a puff of grass-like leaves, reaching heights of over 160 feet. Its cousin, sigillary, had a similar form, but with a distinctive diamond-patterned bark. Then there were the calamites, the giant horsetails, forming dense bamboo-like thickets along waterways, their hollow, jointed stems rustling in the constant moisture-laden breeze. And everywhere, the ferns, not just small understory plants, but tree ferns with thick, fibrous trunks and massive, arching fronds that created a dense, multi-layered canopy, blocking out much of the sunlight and casting the forest floor into a permanent, damp twilight. This incredible uniformity, the same few genera of plants spanning across millions of square miles, created an ecosystem of breathtaking biomass, but startlingly low biodiversity at the species level. It was a monolithic, green machine, pumping oxygen into the atmosphere and drawing down carbon dioxide at a rate the planet has never seen before or since. The sheer productivity of this system was mind-boggling. With no bacteria or fungi yet evolved to efficiently break down the tough, woody lignin and cellulose in these plants, when they died, they didn't fully rot. Instead, they fell into the ever-present, oxygen-poor swamps and mires, piling layer upon layer of organic matter. Over millions of years, the immense weight of overlying sediment and the Earth's internal heat would slowly cook this peat into the vast coal seams that now fuel our industrial civilization. Every lump of coal you've ever heard of is essentially the compressed, fossilized remains of this one, global rainforest. But this very success, this biological monopoly, contained the seeds of its own destruction. The ecosystem was too perfect, too finely tuned to a very specific set of climatic conditions. It had no resilience, no buffer against change. And change, driven by the plants themselves, was coming. As they voraciously consumed carbon dioxide, a potent greenhouse gas, they began to fundamentally alter the very climate that nurtured them. The global temperature began to creep downward. Simultaneously, the relentless tectonic forces driving Pangaea together began to uplift massive mountain ranges, like the ancestral Appalachians and Urals. These new mountains altered wind patterns and created rain shadows dry regions on their leeward sides. The uniform, soggy paradise started to fracture. Areas began to seasonally dry out. For the first time in tens of millions of years, these rainforest giants experienced drought, and they were completely unprepared. Their shallow root systems, adapted to swampy ground, couldn't seek out deeper water. Their reproductive strategies, often reliant on water for sperm to swim to eggs, failed in drier conditions. The monolithic jungle began to break apart, fragmenting into isolated green islands in an increasingly arid world. This fragmentation was the beginning of the end, a process scientists call the Carboniferous rainforest collapse, and it happened with shocking speed on a geological time scale, perhaps within a few 100,000 years. The collapse was not a single event, but a cascading failure, a domino effect where the change in one variable atmospheric CO2 triggered climatic shifts that the supremely specialized ecosystem could not withstand. The evidence for this is etched into the rock record globally. In coal seams around the world, the thick, pure bands of coal from the peak rainforest era are abruptly overlain by layers of siltstone and sandstone, sediments typical of rivers and much drier floodplains. The fossil pollen changes dramatically, showing a decline in the rainforest specialists and an increase in spores from dry-adapted ferns and seed plants. A stark geological tombstone marking the death of a world. The immediate aftermath of the collapse was a world in chaos, a planetary reset that reshaped the destiny of all life. The silent, dripping cathedrals of green were replaced by a patchwork of environments, dry scrublands, seasonal river valleys, and pockets of surviving wetland forest clinging to the wettest refuges. This environmental fragmentation was a catastrophe for the specialized rainforest fauna. Many species of giant insects and specialized amphibians that had evolved in the stable, humid world simply vanished, their niches gone forever. The vacuum left by the retreating giants, however, created the greatest evolutionary opportunity the terrestrial world had ever seen. Into these new, challenging, and variable environments stepped a new kind of creature, one that carried its own private pond, the amniotes, animals that laid eggs, with protective shells and membranes. These were the early reptiles, and crucially, the ancestors of all mammals. The dry, seasonal world that was a death sentence for a moisture-dependent amphibian was a wide-open frontier for these pioneers. They could venture far from water, exploit new food sources in the drier scrub, and their scaly skin prevented water loss. This is the profound, counterintuitive legacy of the collapse. By destroying a stable, lush paradise, it forced innovation. It created the selective pressure that ultimately led to the age of dinosaurs and much later to us. The climate shift triggered by the collapse also had a direct, chilling effect. With carbon dioxide levels plummeting due to the rainforest's own success, the greenhouse effect weakened significantly. This, combined with the new continental geography, is believed by many to have contributed to the onset of the Permian period's Great Ice Age, where evidence shows glaciers spreading across the southern hemisphere continents of Gondwana. The world went from a global hothouse to an icehouse state, a swing driven in part by biological activity. Now let's connect this ancient data to our modern lungs, the Amazon rainforest. The parallels are unsettling and form the core of the original research that makes this story so urgent today. Modern satellite and atmospheric studies reveal that the Amazon, much like its carboniferous predecessor, is a massive, self-sustaining hydrological engine. The trees themselves release vast quantities of water vapor through transpiration, which forms clouds and generates as much as half of the region's rainfall. This creates a positive feedback loop. Forests make rain, which sustains more forests. But this also means the system has a tipping point. Deforestation for agriculture, logging and mining is breaking this cycle. As clear cuts expand, less moisture is pumped into the atmosphere, leading to longer dry seasons and more frequent droughts. The forest, which is adapted to high rainfall, becomes stressed, more susceptible to fires, and begins to die back. Recent studies, such as those published in Nature Climate Change, led by researchers like Carlos Noble, suggest that if deforestation crosses a threshold of around 20 to 25% of the original forest cover, this hydrological pump could fail, triggering a large-scale, irreversible dieback of the Amazon basin, transforming much of it from a lush rainforest into a seasonal, savanna-like ecosystem, a process termed. This is not speculative fiction. It is a quantifiable risk based on climate models and observed trends. The data shows the Amazon is losing its resilience. Dry seasons are lengthening. The frequency of severe droughts, like those in 2005, 2010, and 2015, is increasing. The forest's ability to recapture carbon is declining in some areas. We are seeing, in real time, the fragmentation and stress that preceded the Carboniferous collapse. The key difference and the most terrifying part is the timescale. The Carboniferous collapse unfolded over hundreds of centuries. The anthropogenic pressures we are exerting could trigger a similar biome shift in a matter of decades. Furthermore, the Carboniferous world had no external driver of temperature rise. Our world does. The billions of tons of greenhouse gases we release by burning the very coal that ancient rainforest became. So we are simultaneously applying two immense pressures: local deforestation that cripples the rainforest's self-watering mechanism, and global climate change that increases temperatures and alters weather patterns, making the environment more hostile. This double whammy accelerates the process toward the tipping point. Scientists use the term compound events to describe this, when multiple stressors converge to produce an impact greater than the sum of their parts. The ancient collapse shows us the end result of a biome pushed beyond its limits. The modern data shows us we are actively, knowingly, pushing the world's greatest remaining rainforest toward that same precipice. It is a controlled experiment with our planet's life support system, and the prehistoric record is the lab notebook from the last time it failed. The story deepens when we examine the silent, slow-motion actors in this drama, the fungi and microbes. In the Carboniferous, the inability of decay organisms to break down lignin was the key reason for the massive coal formation. This created a bizarre carbon cycle, where carbon was sucked from the atmosphere by plants, buried in swamps and locked away for millennia, never returning to the air as CO2. It was a one-way street into geological storage. This changed dramatically after the collapse. The evolutionary arms race never stops. In the challenging new environments of the late Carboniferous and Permian, fungi finally evolved the complex enzymatic toolkit, specifically a class of enzymes called lignin peroxidases needed to efficiently decay tough wood. White rot fungi appeared on the scene. This was a revolution in decomposition. Now, when a tree fell, fungi could break it down completely, recycling its carbon back into the soil and atmosphere much more rapidly. The age of massive global coal swamps was effectively over because the carbon cycle had found a new, faster gear. This microbial innovation had a planetary impact. It stabilized the carbon cycle, preventing the runaway drawdown of CO2 that helped trigger the initial cooling. It also created rich, organic soils that supported new types of plant communities. This illustrates a profound Earth system principle. Biology doesn't just respond to the environment, it actively engineers and regulates it over geological time. The rise of decomposers put a brake on the extreme climate swings initiated by the plants. Now, let's project this concept onto our modern crisis, the permafrost in the Arctic. Vast tracts of permanently frozen ground hold an estimated 1,400 to 1,600 billion metric tons of organic carbon, almost twice the amount currently in the atmosphere. This is a legacy of the ice ages, a frozen Carboniferous-style carbon bank, as anthropogenic. Global warming heats the Arctic at more than twice the global average rate. This permafrost is thawing, and just like in the Permian, the microbes are waking up. As the ground thaws, ancient organic matter that has been frozen for millennia becomes accessible to modern bacteria and archaea. They decompose it, releasing carbon dioxide and, in waterlogged conditions, the far more potent greenhouse gas, methane. This is a positive feedback loop of the most dangerous kind. Warming causes thaw, which releases gases that cause more warming, which causes more thaw. Recent studies, like those from the Permafrost Carbon Network, indicate this process is already underway, moving from a theoretical threat to an observable source of emissions. The terrifying unknown is the rate. The Carboniferous Permian transition shows us that microbial communities can fundamentally alter planetary geochemistry, but they did so over hundreds of thousands of years. We are initiating a similar release of stored carbon, but we are compressing the timescale from millennia into centuries or even decades. The system may not have time to adjust smoothly. This microbial feedback is the sleeping giant of climate change, and we are poking it awake with our fossil fuel emissions. Furthermore, the ancient record shows us the importance of connectivity. The uniform carboniferous rainforest was fragile because a climate shift in one area affected the whole vast system due to its homogeneity. Our modern world, through globalization, has created a different kind of uniformity in connectivity, economic and agriculture, that is just as fragile. Our global food system relies on a handful of staple crops. Our supply chains are interlinked. A climate-induced crop failure in one major breadbasket, amplified by extreme weather events, made more common by climate change, can cause price shocks and famine across the globe. The fragmentation of the rainforest led to extinction for specialists but opportunity for generalists. In our human context, this translates to vulnerability for highly specialized nations or communities like low-lying island states or drought-prone agricultural regions, and potential, though chaotic, adaptation for more diversified and resilient societies. The lesson is that monolithic systems, whether biological or human-made, are vulnerable to shocks. The data urges us to build redundancy, diversify our energy and food sources, and create systems that can absorb disturbance rather than catastrophically fail. Investing in distributed renewable energy grids, regenerative agriculture that builds soil health, and preserving genetic diversity in crops are not just environmental slogans. They are strategies for survival informed by 300-million-year-old wisdom. The collapse teaches us that the ultimate survival trait is not dominance in a stable environment, but resilience in a changing one. Our current economic and environmental model prizes short-term efficiency and growth above all else, creating a hyper-specialized, interconnected global system. The paleontological data screams that this is the exact opposite of a long-term survival strategy for a species facing planetary scale change. Moving from the microscopic to the planetary scale, we must confront the most dramatic piece of data from the deep past that contextualizes our current crisis, the Great Dying, the end Permian mass extinction about 252 million years ago. While separated from the Carboniferous collapse by about 50 million years, it is the ultimate cautionary tale of a climate system pushed into a runaway state. The end Permian extinction, where over 90% of marine species and 70% of terrestrial vertebrate species vanished, was likely triggered by massive, prolonged volcanic eruptions in what is now Siberia. These eruptions did more than spew lava. They baked vast deposits of coal and limestone, releasing unprecedented amounts of carbon dioxide and methane. Sound familiar? It was a natural, but extreme, version of what humans are doing today by burning fossil fuels. The result was a catastrophic cascade, rapid global warming, ocean acidification, and most lethally widespread oceanic anoxia, where warming waters lost their oxygen, suffocating marine life. Here is the critical link to our narrative: the pace of carbon release. Recent research analyzing the isotopes in rocks from that period has attempted to pinpoint how fast the Siberian Traps volcanoes release their carbon. Estimates vary, but leading studies suggest the main pulse of emissions occurred over a period of as little as 10,000 to 60,000 years. That pace was fast enough to overwhelm Earth's normal buffering systems, like silicate weathering, which slowly draws down CO2 and causes catastrophic change. Now, compare that to humanity. Since the Industrial Revolution began in earnest around 1850, we have released over 2,400 billion metric tons of CO2. The rate at which we are pumping carbon into the atmosphere is now estimated to be at least 10 to 100 times faster than the rate that triggered the worst mass extinction in Earth's history. Let that data point sink in. We are conducting a planetary-scale geochemical experiment at a speed that makes one of nature's most violent volcanic episodes look slow and gradual. This is the shocking, original core of the scientific warning. It's not just that we are changing the climate, we are changing it at a rate that is geologically unprecedented, outside the bounds of most natural variability that life has experienced and adapted to over the past several hundred million years. The end Permian event shows us the end game of extreme, rapid carbon release, a profoundly inhospitable planet. It took life millions of years to recover its diversity. When scientists today run climate models with high emission scenarios, they are not creating abstract doomsday fantasies. They are sketching the early stages of a trajectory that the rock record proves leads to a biological. The data from the past is not a perfect analog. The continents were different, the sun was slightly fainter. But the fundamental physics of greenhouse gases and the biochemistry of life's limits are constants. Another profound insight from this deep time data is the concept of climate lag. The full warming effect of CO2 emissions isn't felt immediately. The oceans absorb vast amounts of heat and carbon, delaying the atmospheric temperature rise by decades. In the geological past, this lag played out over centuries and millennia. Today, it means that the warming we are experiencing now is largely the result of emissions from the 1980s and 1990s. The emissions we are releasing today will bake in more warming for our children and grandchildren. We are committing future generations to a changed world based on the decisions we make now. This intergenerational injustice is mirrored in the fossil record. The action of the Siberian volcanoes doomed countless future generations of species. Furthermore, the ancient record demolishes the comforting myth of a stable Earth. Our planet's history is a roller coaster of hoe houses and ice houses, of high oxygen atmospheres and low oxygen oceans. Stability is the exception, not the rule. The relatively mild and stable climate of the last 12,000 years, the Holocene epoch in which human civilization developed, is a rare sweet spot. The data tells us we are now forcibly exiting that sweet spot and entering a new human-made climatic state, the Anthropocene. The past shows that such transitions are rarely smooth. They are characterized by tipping points, thresholds, and abrupt shifts, exactly the nonlinear behavior modern climate scientists are desperately trying to quantify and predict. The worry is not a gradual, linear increase in temperature that we can slowly adapt to. The worry is crossing a threshold like the dieback of the Amazon, collapse of the West Antarctic ice sheet, or the irreversible thaw of permafrost that flips the system into a new, irreversible state with devastating speed. The Carboniferous rainforest crossed such a threshold. The end Permian world crossed a far more terrible one. The data is screaming that we are approaching multiple thresholds of our own making. So where does this leave us, with the weight of 200 million years of planetary history on our shoulders? It leaves us at the most consequential crossroads our species has ever faced. The ancient script has been written in stone and coal. Our chapter is being written in real time by our collective actions. The story of the Carboniferous rainforest and its collapse is not a prophecy of inevitable doom. It is a diagnostic tool, a paleontological MRI showing the vulnerabilities of complex life systems. It tells us what happens when a biological monopoly meets climatic change. It shows us the creative destruction that follows collapse, but also the unimaginable loss and the millions of years of recovery required. The message is not that we are doomed, but that we are playing with forces that have reshaped the very face of life on Earth. And we are doing so with the casual recklessness of a child playing with a lit match in a room filled with the coal dust of ancient forests. The hook of this entire narrative, the stone jungle, the lost world, is our reality. If we view our current environmental crisis through a shallow, short-term lens. But if we view it through the deep-time lens, we gain something priceless: perspective, and with it, a roadmap for urgent action. The first directive from the data is unequivocal: stop the deforestation. protect, and massively reforest. This is not just about saving cute animals. It is about maintaining the functional life support systems of our planet, the rainfall cycles, the carbon sinks, the reservoirs of biodiversity that provide genetic resilience. Every standing forest, especially the tropical ones, is a bulwark against the kind of catastrophic biome shift we've been discussing. We must support policies and companies that have verifiable zero-deforestation supply chains. The second directive is to leave the fossil fuels in the ground. This is the hardest but most non-negotiable step. Burning coal, oil, and gas is literally pouring the stored instability of past climates into our already overburdened atmosphere at a breakneck pace. The transition to renewable energy, solar, wind, geothermal, next-generation nuclear is not merely an economic or technological challenge, it is a geophysical imperative. The speed of this transition must match, and then exceed, the terrifying speed of the ancient volcanic pulses we now outpace. The third directive is to invest in adaptation and resilience with the seriousness of a species preparing for a known, coming storm. Our coastal cities need redesigned infrastructure. Our agriculture needs to become climate smart. We need to plan for water security, climate refugees, and the preservation of genetic diversity in all its forms. This is not defeatism, it is pragmatism informed by a planet that does not forgive those who ignore its rules. Finally, and perhaps most importantly, we must change the story we tell ourselves. We have to move from a narrative of human dominion over a stable, inert planet to one of human interdependence within a dynamic, living, and fragile Earth system. We are not separate from nature. We are a part of its most recent powerful and conscious chapter. The power we wield is the power of the Siberian traps volcanoes, but coupled with foresight and choice. The call to action, therefore, is multifaceted and immediate. It starts with you right now as you finish this sentence. First, become relentlessly informed. Seek out science, not sentiment or sensationalism. Follow climate scientists and scientific organizations on social media. Read the IPCC report summaries for policymakers. Understand the data, because the data is the only true map we have. Second, use your voice and your vote. Demand that every politician at every level has a serious, detailed, and science-based plan for decarbonization and ecological protection. Vote for the climate in every election. Make it the non-negotiable issue, because it is the issue that underpins the economy, national security, and public health. Third, scrutinize your consumption. You don't have to be perfect, but be conscious. Reduce meat consumption, especially from deforestation-linked sources. Minimize waste. Choose renewable energy options if available. Support sustainable businesses. Your daily choices shape the market. Fourth, have the conversation. Talk to your family, your friends, your colleagues about this deep time perspective. Share this video. Break the spiral of silence and climate anxiety with grounded, factual discussion. We are social creatures, and change spreads through networks. Finally, and this is crucial, cultivate hope through action. The worst thing we can do is succumb to despair and apathy. Despair is a luxury the data does not afford us. Every fraction of a degree of warming avoided, every hectare of forest preserved, every policy shifted towards sustainability matters immensely. It matters for the stability of the Amazon, for the preservation of coral reefs, for the security of food systems, and for the future of every generation to come. The ancient rainforests fell because they could not adapt to the change they themselves helped create. We have a unique gift, the ability to see the change coming, to understand its mechanisms from the deep past, and to choose a different path. We can be the first species to read its own geological obituary in advance, and then decide to rip it up and write a new story. The final, most engaging call to action is this: don't just be a viewer of history, be an author of the future. Start today, right now. Subscribe to this channel for more deep dives into the science that defines our fate. But more importantly, hit the share button. Share this video with one person you think needs to see it. Send it to a friend, a family member, or post it on your social media. Let's spread this understanding, this deep time perspective, like the most vital information in the world, because it is. Then, in the comments below, tell me one specific action you will take this week, informed by this 300 million-year-old story. Will you contact a representative, change a dietary habit, research a sustainable investment? Let's build a community of action in the comments, a digital seed bank of ideas and commitment. The clock of the ancients is ticking. But unlike the giant ferns of the stone jungle, we are not rooted in place. We can move. We can change. We must. The next chapter is ours to write. Let's make it one of resilience, wisdom, and a profound, learned respect for the only planet we call home.